Hyperbola. A hyperbola is a set of all points in a plane, the difference of whose distance from two fixed point in a plane is a constant, right? So, see, if I draw one figure and take two fixed point as my focus of hyperbola, then if I take any point on this curve, say S1, and these are our two fixed point S1 and S2, then the difference, the positive difference, that is here S2P1 minus S1P1 will be a constant. Now, see, if I take another point, say P2, then here S2 P2 minus S1 P2 will also be the same value, and it will always be that same constant. If I take another point on, say, this parabola, say P3, you should take more. You try to understand that. I will take just a positive difference. So if I subtract S1 P3 minus S2 P3, then I will get the same value, but constant. So this is how we get hyperbolas, right? So here you can see that the opening of this hyperbola is towards x-axis. Therefore, the transverse axis is x-axis, whereas conjugate axis is y-axis. We have one more type of hyperbola where the opening of this hyperbola is towards y-axis. In this case, my transverse axis will be y-axis, and my conjugate axis will be x-axis. We'll have different set of formulas for the hyperbola having transverse axis as x-axis and transverse axis having y-axis. Right. Again, here the value of eccentricity will be greater than 1. We have that value of eccentricity is less than 1 in ellipse. Here we will have the value of eccentricity greater than 1. Right. So let's try to understand the standard equations of hyperbola and the terms related to it and the formulas. So we'll draw two hyperbolas. One is having its transverse axis as x-axis, and one having its transverse axis as y-axis. Right. And here the equation of hyperbola is x square by a square minus y square by b square is equal to 1. Here we need not to compare the value of a and b that we used to do, right? Because here the standard equation of hyperbola for the transverse axis as y-axis will be x y square by b square minus x square by a square is equal to 1. So you can see that here the coefficient of y square will be negative, here the coefficient of x square will be negative. Here to find the value of eccentricity, we will apply b square is equal to a square e square minus 1. Here the value of e is greater than 1. And here I will apply e square is equal to b square e square minus 1. Here also the value of eccentricity is greater than 1. We will have two fixed points, that is foci, which will be at plus minus a comma 0, vertices plus minus a comma 0, equation of directrix x is equal to plus minus a by e. 1 will be over here, x is equal to a by e, and 1 will be over here, x is equal to minus a by e. Length of transverse axis is 2a. Length of conjugate axis is 2b. Length of latus rectum is 2b square by a. Right. Here my foci will be on 0 comma plus minus be. These are the two fixed points, 0 comma be, 0 comma minus be. Then vertices will be 0 comma plus minus b. This is that 0 comma minus b, 0 comma plus. Right. Equation of directrix y is equal to plus minus b by e. This will be y is equal to minus b by e, and this will be y is equal to plus b by e. There will be some distance between them. Here I am not having space, that's why I have length of transverse axis is 2b. Length of conjugate axis is 2a. And length of latus rectum is 2a square by b. See, latus rectum is a line passing through the focus and exactly perpendicular to transverse axis. So here we will get two latus rectum, and the length is the length of this line segment between these two points. Right here also we will have this latus rectum, and one more will be over here. So latus rectum is a line segment perpendicular to transverse axis and passing through focus. Here the intersection of transverse axis and conjugate axis will be origin. So you can see that my focus will be on either on x-axis or in y-axis. That is, my transverse axis will be either x-axis or y-axis. We do have hyperbolas whose transverse axis and conjugate axis are not our coordinate axis, but we will deal with that type of hyperbolas in higher classes. See, see what happens if the value of a and b gets equal. That is it. The standard equation of hyperbola having transverse axis as x-axis is x square by a square minus y square by b square is equal to 1. But if I take my value of b as a only, then here I will get this type of hyperbola, which is called as equilateral hyperbola. Therefore, the equation of this type of hyperbola will be x square minus y square is equal to a square. It can be y square minus x square is equal to a square if the transverse axis is y axis. So you should understand that hyperbola having its value of a and b equal will be called as equilateral hyperbola. Now we can start with exercise 11.4. Question 1. In each of the exercise 1 to 6, that is question 1 to 6, find the coordinates of the foci, vertices, eccentricity, and the length of lattice vector. So here we need not to compare the value of a and b that we were doing in uh, ellipse. Here uh, the coefficient of x or y will be negative, which will tell me the transverse axis. As you can see that here the coefficient of y square is negative, I will write transverse axis is x-axis, and I will recall the formula, all the formulas related to transverse axis as x-axis. So on comparing with x square by a square minus y square by b square is equal to 1, the value of a square is 16, b square is 9, therefore a is 4, b is 3. We'll find the value of eccentricity using formula b square is equal to a square e square minus 1. So here 9 is equal to 16 e square minus 1. Therefore 9 by 16 is equal to e square minus 1. Therefore e square is 9 by 16 plus 1. Therefore e square is 25 by 16 and e is 5 by 4. You can see that the value of eccentricity is greater than 1. Now loci, as it is the transverse axis is x-axis, I will have on the x-axis only plus minus a comma 0. The value of a is 4. The value of eccentricity is 5 by 4 comma 0. So plus minus 5 comma 0. Vertices, I know that it is plus minus a comma 0. So plus minus 4 comma 0. And the last is length of lattice rectum. Here it will be 2b square by a. 2 into the value of b square is 9, whereas the value of a is 4. So 2 1 2 2 I will get the length of lattice rectum as 9 by 2. Right. Let's try to do the second question. Here the standard equation of hyperbola given is y square by 9. You can see that this time you are getting the coefficient of x square as negative. Y square by 9 minus x square by 27 is equal to 1. Definitely transverse axis is y-axis. So I will recall all the formulas pertaining to the transverse axis as y-axis. So on comparing with y square by b square minus x square by a square is equal to 1. My b square is 9, a square is 27. So b is 3, a is this will be 3 root 3, 9 threes up, and root 9 is 3, right? So here I will apply the formula. A square is equal to b square, e square minus 1. So 27 is equal to 9 e square minus 1. This will be 1 that, this will be 3 that. So 3 is equal to e square minus 1, and for e square is equal to 4. Therefore, the value of e is 2. Right. Now, we got the value of e. We'll find the foci which is on plus minus be. So the value of b is 3, the value of e is 2, and we get the value of foci as 6 plus minus 6. Vertices, it is on 0 comma plus minus b. So 0 comma plus minus, the value of b is 3. So I got my value of eccentricity as 2, foci is on 0 comma plus minus 6, vertices are on 0 comma plus minus 3, and the last is length of lattice rectum. So length of lattice rectum is 2a square by b, right? So 2 into the value of a square is 27, right? And the value of b is 3. So 3 1 is 3, 9 is 9 2 is 18. Therefore, the length of lattice rectum is 18. See, you might encounter the method given in examples of your textbook is different. But if you will follow this method, then also you will get the correct answer. Whichever method you like it, you can follow that. In both the case, you will get the same answer.